Some solutions to the location problem would involve a centrally managed catalog of objects. Some solutions would use a more decentralized approach with location services run by different operators in different regions of the network. Some schemes would be completely decentralized based on a requester broadcasting a request for an object until a copy is found. These different schemes have very different implications for control, resilience, performance, and utility. The problem of search is distinct from the problem of location. The location problem is to find a copy of an object once the particular object has been identified. The analog in the real world is to ask what library or bookstore has the closest copy of a specific book. The search problem is to look for objects that may match certain selection criteria, analogous to seeking a book on the history of baseball that costs less than $20. Google's approach for finding a good match to given search criteria, for example, is quite complex and sophisticated, which gives Google a high degree of control over what search results are returned and in what order. Another problem that has a critical influence on search is the emergence of dynamic information mentioned above that is generated on demand for each user. It is not clear that current centralized search systems reliably or consistently index information that only exists when a particular user asks to retrieve it. There is ongoing research in the design of advanced search engines that could search of or otherwise deal with dynamic content. A specific example of an information architecture is content-centric networking. This proposal makes the addresses in packets correspond to information elements rather than machines. One sends a packet to a piece of information asking that it be returned and gets back a packet from that address containing the requested information. This reformulation of what addresses means leads directly to new modes of dissemination and in-network storage, such as any-to-any dissemination, demand-driven buffering, and directed diffusion distribution. Information is signed, so validity and provenance are explicit properties of the scheme. And since one does not receive information except when asking for it, the one only receives information that is relevant. So certain security attributes are intrinsic to the scheme. The traditional service of the internet today, conversations between explicit endpoints, can be derived as a tiny part of the total space.